Welcome back, college personal finance students. It's Mr. Clem, and we are going to look over our capital needs assessment. We're going to look at the pure annuity option, which is essentially saying whenever my last day is, last day alive is going to be the last dollar that I have to spend, or I'm going to spend my last dollar the last day I'm living, and the day I die, I'm going to die with nothing, right? No money left aside. So we're going to go over our sample here, and this sample is from a Byron C. Lemon, and he is currently 29 years old, and he's been putting a little bit of money away, and he kind of thought he didn't really know if this was enough. So he wants to do some math to figure out, okay, what do I need? So he's currently 29 years old. He plans to retire at age 65. He thinks he's going to live till 90. Right now at 29 years old, he's pulling home a gross earnings or a wage of $105,000. Now, we could do either the top down approach where we look at current savings and payroll taxes to help us calculate our wage replacement ratio. We could, as you get a little bit older, maybe the Mr. Clem age of in his 50s, you can say, well, let's look at your budget and say, how much do you know you're going to spend in retirement? Compare that to your income and calculate your wage replacement that way. We're not going to do that math today, but what we do have is we've got 78%. That's our wage replacement ratio. The other facts that we know in this situation are we've got Social Security totaling $18,000 a year. Again, notice we called that an annual number. And we currently have 15,000 bucks saved, right? We're 29 years old with 15,000 in the bank. Where that is, I don't know that it matters right now, whether it's a 401k, a 403b, a Roth IRA. I've got 15 grand set aside. I'm feeling like I'm maybe a little bit behind schedule, and I want to figure out how am I doing, right? What do I need to retire on? How much money do I need to retire on? And or how much do I got to start putting away on a monthly basis to make that happen? Now, there's some assumptions, and the assumptions we're going to start here is our investment rate of return. We're assuming the portfolio that we're putting our money in is going to earn 12% a year. That's pretty good, right? Historical averages, the Dow and the S&P, or the S&P is doing about 10% per year. That's a little bit more aggressive than that. And it's only got an inflation of 3. Now, we know these are not constant, right? These are ballpark kind of planning tool numbers that will need to be adjusted over time. We can't just sit and do this one time and say, that's good. Because what if you don't have 12% rate of return every year consistently for the next how many every year? What if inflation changes from 3%? Now, we can say 3 is a number, but for those of us watching this now, it wasn't that long ago. Inflation was 8, 9, almost 10% post-pandemic. So these are the assumptions. These assumptions could change, and logically, we're going to need to make some adjustments there. So we're going to need to calculate and ensure inflation-adjusted rate of return. We're going to calculate our wage replacement ratio. We're going to find out our gross dollars needed. We're going to figure out gross dollars less Social Security, right, your annual amount needed at retirement on the first day of retirement. However, that amount is as of today's dollar. So we're going to need a future value function to push that number forward to say, well, it's worth this today at age, in our case, 29. What's that number going to be at 65? Now, granted, this guy's fairly young, so that number is going to look really big when we get there. We then need to say, on the first day of the year, I need this pile of money at 65, and then another pile at 66, and another pile at 67, all the way up to death age of 90. And then our final step is to say, all right, we know what the pile is supposed to be. By the time we get to age 65, I need this pile of money. $1 million, $2 million, $5 million, whatever the number ends up being. How much do I need to be putting away now at age 29, probably on a monthly basis, to make that happen, right? Our financial planners, our Jake Linders, our Joel Hillmans have far more sophisticated technology to do this, but we can still do it kind of old school function type math here as we work. So let's start. So we're going to start over here with wage replacement ratio. We have that as a set number as 0.78. We're then going to move on to step 2, which is, okay, how much of today's $105,000 am I going to need when I retire? So our math is wage replacement ratio, 78%, times my current annual income of $105,000. So that's how we're going to come up with the answer for step 2. Pretty simple math. We know step 3 is just pulling the annual amount of Social Security. Now, on some of my other assignments, I'm going to maybe give you a monthly Social Security number. Since this is an annual amount of income and we're calculating step 2 as an annual number, we're going to need to calculate Social Security as an annual number. So this one is an annual number. This one is, we've got Social Security for the whole year at $18,000. If you were curious on that math, 18,000 divided by 12, because you get paid once a month, you're getting $1,500 a month. Right? So we're going to take our amount needed to calculate here at step 3, take my $81,000, right? Annual income times wage replacement ratio, then subtract Social Security. I need to replace $63,900 per year. And I know that number, and that's all fine and good. The challenge is I'm 29 years old right now, right? That's a long way from age 65 when I'm going to retire. So I need to take this 63,000 number and I got to send it forward to say, what is that $63,900 going to really buy me when I turn age 65? Well, that's why we got to worry about our inflation. Our inflation right now is currently 3%. 3% meaning every year things get 3% more expensive. So what does this 63,000 number need to be in a handful of years at age 65 so I don't go backwards? So I'm going to write a future value formula. What is the future value of something that is growing at 3%, our rate of inflation, over how long, right? That's the difference between age 65 and 29. 36 years. My payment part of my function 0, am I putting any more in or am I letting any leak out? I'm not. It's just as is. My present value is, well, the present value at age 29 is $63,900. So I could type in that number, or I could say, go ahead and click on this cell right here and do that math. I'm kind of a spreadsheet donkey, so I like writing formulas inside of formulas. And again, do I need it at the beginning or the end? I can go ahead and calculate that at the end. So this $63,000 number fast forwarded over the next 36 years, right? Between current age and retirement age at 3% inflation is going to grow to $185,200, right? Roughly. That's a pretty big number, right? But 36 years is a long time, and 3% inflation adds up pretty quickly. So as of my first day of retirement at age 65, I need a check. I need to draw a pile of money to live on for the year. I need to draw $185,200. And that's all I need if I was going to die at 66. I need 185 to live this year, and after that, I'm done. I've spent my last dollar the last day I lived, and things are done and over with. The challenge is I'm going to need this 185,000 at 66. But it's not going to be exactly 185, 200. It's going to be that plus some investment return and or discounted for inflation. And then I need it again at 67 and 68, blah, 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 all the way to age 90. So our tough formula or our big formula is I need the present value, meaning I need to know what is this bucket of cash need to be as of the day I turn 65. A bucket big enough that I can draw this number knowing that this number is going to grow due to inflation because I don't want to lose purchasing power. And I want that money on day one. I don't want that money at the end of the year. That would be pretty tough to live on a credit card for a year and then go pay it off. I need that pile of money on day one of age 65. So the first thing I need to do is I need to calculate my inflation adjusted rate of return. Now that formula is a little complex. It's in your book. I'm going to take 1 plus my investment rate of return, divide that by 1 plus my rate of inflation. Again, I'm putting in brackets to do my math in a particular order. So 1.12 divided by 1.03, get that math first, subtract 1, and then multiply it by 100. My inflation adjusted rate of return is 8.74%. Now, the way I did this math, it comes up to a whole number of 8.73786, blah, 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 blah. I don't need to put a percent to it. If I put a percent to it, it's going to look like 873%. That's not what I need to do. 8.73, 8.7386%, that's my percentage, my insurance or my inflation adjusted rate of return. So as I start doing my present value of annuity math, I'm going to say, go pull that 8.737 number and then put a percent symbol at the end of it, right, to represent 8.737%. So that's my rate. My N per is, again, I need these monies on an annual basis, so I need them from age 65 to 90. So I just say, take 90 minus 65 and spit out an answer. 25 years. How much do I need, right? The payment part. Well, the payment part is I need this number right here. I need the answer from step 4. The $185,199.99. Future value, again, if this is a capital needs pure annuity, I'm spending my last dollar, my last living day. I don't need any for the kids. The kids aren't getting any when I die. I spent it all, it's gone. Now, there are other options. You could say, well, I want to have a pile of money that I can live on, but then I want to give my kids $100,000. Well, then this zero needs to change to be 100,000. Or I want to leave $1 million to my kids, $500,000 each. Well, again, then this number here would need to be $1 million, right? So the future value part of the function is how much are you leaving over the day you die at age 90 in this example. And then again, the key is my type needs to be 1, right? I want this number at the January 1st date. I don't want this number on December 31st. So I go ahead and do that math. Equals present value, equals present value, inflation adjusted interest rate. For how long? With a payment stream of 185, 199.99. Again, it's a present value of an annuity, and technically it's an annuity due. That's why it will be ending with a 1. So I need a big old pile of cash. I need a little more than $2 million to make this thing happen. Awesome. I'm sitting here with $15,000 as of today, age 29. how much do I need to start putting away so that that pile between age 29 and 65 will grow to this $2 million number? So we're going to use a payment function to do that math for us. In the payment function, we have the rate, we've got the N per, we've got the present value, we've got the future value, and we've got the type. Right? So with most of us, we're going to drop in money monthly. Some of us may do it every paycheck. So technically we could divide this by 24 and then multiply it by 24, but I want to make it a little easier. We're just going to do this monthly. Right? So my payment function, knowing that my chosen investment is going to return a 12% rate of return, I've got a payment function that says, go ahead and take my 12% investment rate of return and then go ahead and divide it by 12 because we're doing it monthly. My time frame from age 29 to 65 is going to be 36 years. And again, I'm going to multiply that by 12 because I'm going to turn that into monthly. So turn your annual rate of return, your 12%, into a monthly number. Take your annual years of saving and turn those into monthly numbers. Present value is how much money do I already have saved? Future value is how much is my big old bucket need to be? Right now, these two numbers need to be opposites. Right? I need a negative on the 15,000 because that's what I've already got, and it needs to grow to little more than 2 million. And I'm doing at the end of the year. So I'm spitting out, I need $126.32 on a monthly basis for the next 36 years with my existing $15,000, assuming my rate of return is going to be 12%.